To all, today we are going to discuss about elastic properties of solid. As studied earlier, we defined some terms, that is stress, strain, elasticity, and now we are going to discuss about Hooke's law. Hooke's law establishes a relation how much strain produced in a substance by application of a given stress. This law states that within elastic limit, stress acting on a substance is directly proportional to strain produced in it. That means mathematically कहले within elastic limit stress proportional to strain. That implies stress by strain is a constant quantity. Known as coefficient of elasticity or modulus of elasticity denoted by E. जोटी E टाको हमें उटे constant नाम से called coefficient of elasticity or modulus of elasticity. That is the coefficient of elasticity or modulus of elasticity. Its dimension and unit same as that of stress above. Unit of coefficient of elasticity or dimension of coefficient of elasticity is same as stress by strain dimension or unit. As strain has no unit and a dimension, so it is same as dimension of stress, which is dimension of pressure m1 L minus 1 T minus 2. Its unit same as unit of stress, that is Newton per meter square or Pascal. Here we have to know what do we mean by elastic limit. As we already studied, that is when a body is elastic substance is deformed by application of external force, then when that deforming force, external force is removed, the body try to regain its original configuration. The limiting force or stress within which deformation is completely recoverable is known as elastic limit. The maximum stress or load within which deformation is completely recoverable is known as elastic limit. ला ताले गोटे वस्तु को बल देले सेटा विरूपित हम बल काढ़ी नेले सेटा मूल अवस्था को फेरी जावाक चाहिए ताहले जो सीमा भितर बल देकी आम बल काढ़ी नेले वस्तु संपूर्ण मूल अवस्था को फेरी आसुची से लिमिटा को आम कहवा इलास्टिक लिमिट. The point corresponding to maximum stress or maximum load within which deformation is completely recoverable known as elastic limit. ताले से इलास्टिक लिमिट भितर स्ट्रेस स्ट्रेन परस्पर सह समानुपाती हेबे. स्ट्रेस इज प्रोपोर्शनल टू स्ट्रेन हम और स्ट्रेस वर्सेस स्ट्रेन ग्राफ बिकम्स दैट इज लिनियर हम. ताले टेकिंग स्ट्रेस along x axis and a strain along y axis. If we plot a graph, then the graph becomes straight line up to a certain point, then becomes non-linear. तापर एटा non-linear हो. The maximum limit up to which stress versus strain graph becomes straight line is known as elastic limit. ये जो पॉइंट को आम कहवा दैट इज ए पॉइंट इलास्टिक लिमिट हम. तापर आम लोड कले सेटा नॉन लिनियर हम. तो स्ट्रेस वर्सेस स्ट्रेन ग्राफटा कर्व लाइन हम. ताले beyond elastic limit if we load a substance then unload it will never return back to its original configuration. That means we get finally deformation even at a zero load. आम ओ डैश पॉइंट रे पहुँचवा है. ताले इलास्टिक लिमिट के अतिक्रम करी जदि अधिका लोड दबा देन अनलोड कले आउ से मूल अवस्था को फेरबनी है. अर्थात इवन जीरो लोड रे आम फाइनाइट डिफॉर्मेशन पाइबा है. फाइनाइट एलोंगेशन पाइबा है. दैट दिस इज नोन एज इट्स प्लास्टिक स्टेट है. ताले प्लास्टिक स्टेट रे आम गोटे पॉइंट पाइबा जो पॉइंट को आउ सामान्य टिके लोड ऐड कले है. आम देखा देयर विल बी large elongation or strain produced in the substance. से पॉइंट को आम कहवा एल्ड पॉइंट. ये आम सामान्य टिके लोड जदि ऐड करवा ताहले देखा एक्स्ट्राऑर्डिनरी एलोंगेशन हम. लार्ज अर्थात ग्राफटा ये मीट करवाटे इनफाइनाइट है. ताले ये पॉइंट को आम कहवा एल्ड पॉइंट. Beyond yield point, if we add more load, then body will be breakdown after a given load. That is known as a breaking stress बोले आम कहवा है. ताले से yield point पर जदि आम फर्दर लोड ऐड करवा ताहले body will break down है. ताले the corresponding stress at which body will break down is known as a ब्रेकिंग स्ट्रेस है. ताले स्ट्रेस वर्सेस स्ट्रेन ग्राफ रू आम केते गुड़िए टर्म्स जानूचे. ताले इफ वी प्लॉट ए ग्राफ टेकिंग स्ट्रेस along x axis, strain along y axis, then the graph becomes straight line up to a certain point a. The point corresponding to the maximum stress corresponding to point a within which डिफॉर्मेशन इज कंप्लीटली रिकवरेबल. आम ए पॉइंट भितर वस्तु को लोड करके अनलोड कले से संपूर्ण मूल अवस्था को फेरी आसो. अर्थात ए पॉइंट रू आम अनलोड कले से बाट देकी जो पॉइंट देकी जाइए से पॉइंट रे एटा ओ पॉइंट रे पहुँचब. अर्थात डिफॉर्मेशनटा कंप्लीटली रिकवरेबल हम. बट बियॉन्ड इलास्टिक लिमिट इफ वी ऐड मोर लोड or more stress, then stress becomes no more proportional to strain. That means stress versus strain graph becomes non-linear or curve line. Beyond elastic limit, by loading a elastic substance, if we unload it, then even at a zero load we get finite deformation or elongation. But that means body is permanently deformed from its original state. This is known as its plastic state. In plastic state, if we add more load, then we get a point at which by addition of a small load there will be large elongation take place. That point is known as a yield point. Point corresponding to C is known as a yield point. Beyond the yield point, if we add more load, then body will break down for a given load, known as a breaking stress or breaking load बोली हमें कहबा. ताले से प्लास्टिक स्टेट एरू एबव रीजन टाको हमें object रो गोटे प्लास्टिक स्टेट बोली कहूँ से the state of elastic substance which comes after when it cross over the elastic limit. ताले plastic state is the state of an elastic substance which comes after when it cross over the elastic limit. Depending on the longevity of a plastic state, how long it retain its plastic state, depending on that we can classify substance into two classes. One is that is ductile substance and brittle substance. Those substance which continue its plastic state for a long time even after passing through elastic limit, that substance is known as a ductile substance. Almost all metallic substance are ductile. Elastic limit अतिक्रम कला परे जे तार plastic state को long time attain करछि before breakdown, then that substance is said to be ductile substance. Metallic substance would are ductile. कहीं ना इलास्टिक लिमिट अतिक्रम कला परे सेटा अनेक समय पर्यंत तार प्लास्टिक स्टेट को अटेन करछि धारण करछि. ड्यू बिकॉज ऑफ इट्स डक्टाइलिटी प्रॉपर्टी फ्रॉम मेटल वी कैन ड्रॉ वायर्स. आमे तादरु तार तयारी करि परछे मेटल रु तार डक्टाइलिटी प्रॉपर्टी जोगु. ब्रिटल सब्सटेंस कोन व्हिच विल ब्रेक डाउन जस्ट आफ्टर पासिंग थ्रू इलास्टिक लिमिट is known as that is brittle substance. हमर ग्लास क्वार्ट्ज माइका एगुटा को हमें कहबा ब्रिटल सब्सटेंस जहार प्लास्टिक स्टेट नाही बा प्लास्टिक इलास्टिक लिमिट अतिक्रम करबा परे परे जे भांगी जाउछि ब्रेक डाउन hi जाउछि हला से सब्सटेंस को हमें कहबा that is a brittle substance. हला तला however Hooke's law हमें जान ले that is elastic limit, yield point कौन जान ले हला that is plastic state कौन जान ले that is plastic state longevity अनुसार हमें दी प्रकार substance कहले that is brittle substance and ductile substance. Now different types of modulus of elasticity. Depending on different types of stress and strain, we have coefficient of elasticity or modulus of elasticity is stress by strain. So depending on different types of stress and strain, we can define following three different modulus of elasticity. That is Young's modulus, y वाली सिंबल दूँ हमें कैपिटल Y, बल्क मॉडुलस, इट इज B, और आम के बेली मध्य सिंबल को बही लिखुची के, बल्क मॉडुलस, मॉडुलस ऑफ रिजिडिटी और शियरिंग मॉडुलस. That is eta. First time पढ़िबा Young's modulus. Young's modulus y, it corresponds to change in length by application of normal stress. Change in length by normal stress. That means Young's modulus may be defined as a ratio of change in length Young's modulus of substance may be defined as ratio of normal stress to the corresponding longitudinal strain produced in the substance. Ratio of normal stress to the corresponding longitudinal strain. Produced in the substance. That is, suppose this is a where when it is given a certain load, then elongation produced in it. निर्दिष्ट लोड elongation हम. Suppose it is its original length is L elongated through delta L by application of normal stress, that is weight mg. So Young's modulus becomes mathematically y is equal to कहवा, that is stress by strain, which is equal to normal stress, it is force by cross sectional area divided by volumetric strain, longitudinal strain, which is delta L by L. This is your Young's modulus, that is FL by A delta L. एठी हमें F एटा को weight बेलून से mg L divided by हमें यदि cylindrical cross sectional wear नबा ताले A जगह we can write it as a pi r square into delta L. This is your the capital L नीचे में capital L नबा, that is longitudinal strain, delta L by capital L. Whereas stress force by area, here force is the weight and the area is cross sectional cross section of wear, that is pi r square. So here unit of Young's modulus is the same as unit of stress, that is unit of Y same as unit of stress, that is Newton per meter square. We can define stiffness or force constant, that is the quantity force per unit extension is known as a force constant or stiffness of a substance. Stiffness or a force constant is equal to force per unit length, which is equal to force per unit length habo, that is YA by L. This is known as a stiffness or a force constant, which is directly proportional to area of cross section and inversely proportional to length. Stiffness of a substance is directly proportional to area and inversely proportional to its length. Cross sectional area cross sectional area बढ़िले stiffness टा बढ़िबो, but length बढ़िले stiffness टा कमिबो. This is all about Young's modulus of a substance. Then now we have to define bulk modulus. Bulk modulus, it corresponds to volumetric strain produced in the substance by application of normal stress or normal pressure. Bulk modulus of a substance may be defined as a ratio of normal stress or normal pressure to the corresponding volumetric strain produced in the substance. To the corresponding volumetric strain produced in the substance. Normal pressure by volumetric strain. If by application of normal pressure compression take place in a substance, its volume decreases by amount to delta V. Original volume is V, change of volume delta V. So normal pressure P by volumetric strain, we can write minus delta V by V. Minus sign is due to increase of pressure causes decrease of volume. So B is equal to minus PV by delta V. If volume increases with increase of pressure, then we take positive sign, that is PV by delta V. So volume जदि increase हबो ताले positive sign हबो. If volume increases, delta V टा positive हबो, volume increases. एटा वॉल्यूम टा डिक्रीज होंसी विथ प्रेशर, से नेगेटिव साइन नहीं. जदि वॉल्यूम इनक्रीज हम विथ प्रेशर, देन अर्थात ब्लाडर टा एक्सपांड हम बाय गिविंग इनर प्रेशर. सो बल्क मॉडुलस बिकम्स पॉजिटिव. ताले एटा पॉजिटिव बा नेगेटिव हो पारे बल्क मॉडुलस हला. ताले बल्क मॉडुलस रो रेसिप्रोकल को आमे कंप्रेसिबिलिटी नबा. Reciprocal of bulk modulus is known as a compressibility. One by bulk modulus, which is equal to 1 by B. Compressibility. Unit of bulk modulus is same as unit of pressure, that is Newton by meter square or Pascal. So unit of compressibility is reciprocal of unit of bulk modulus, that is meter square Newton inverse. Solid and liquid almost incompressible, hence possess less compressibility but large bulk modulus. Plus solid and liquid are almost incompressible, so possess large value of K, B, possess compressibility low होबो. bulk modulus large होबो, compressibility low होबो. But gas are easily compressible. So it has a value of bulk modulus low होबो and compressibility high होबो. Finally आमर modulus of rigidity और elasticity और shear modulus भी आपको कौन से. or shear modulus. It is denoted by eta. It corresponds to shear strain, shearing strain by tangential stress. That means shear modulus or modulus of rigidity eta becomes tangential stress by shearing strain. Tangential stress to the corresponding shearing strain produced in the substance. हमें previously कहीं गोटे रेक्टांगुलर ब्लॉक तार बेसटा को फिक्स रखी जदि आम टेंजेंशियल फोर्स अपर फेस रे दबा देन इट गेट डिस्प्लेस्ड फ्रॉम ए बी सी डी पोजिशन टू A dash B dash CD position. This is the angle of shear produced by given tangential stress T. A tangential stress tower, tangential force by area, whereas the shearing strain measure करिबा में एटा डेल्टा x एटा दी x अब ताले shearing strain becomes delta x by x. So eta is equal to normal stress tangential stress by shearing strain theta, which is equal to tangential force by area divided by delta x by x. So it becomes fx by a delta x. This will measure your shearing strain. That is shear modulus or modulus of rigidity, modulus of elasticity. Eta. Unit of eta is same as unit of tangential stress, that Newton by meter square or Pascal. It is also known as a torsional rigidity. Eta is also known as a torsional rigidity of substance. We can define another elastic constant that is known as a Poissons ratio. Sigma. It will be observed that when a substance is longitudinally extended, then it is simultaneously laterally compressed. गोटे सब्सटेंस को आम नॉर्मल स्ट्रेस देले जितेबाला सेटा एक्सटेंशन होची देखिबा लैटरली कंप्रेस हबो बाय गिवन नॉर्मल स्ट्रेस. समान नॉर्मल स्ट्रेस रे when elastic rubber band is extended, then it is laterally compressed. So two types of strain produced in the substance by given normal stress. The ratio of these two types of strain, that is longitudinal strain and lateral strain. These two type of strain produced in the substance is known as a ratio of these two strain is known as a Poissons ratio. It is defined as the ratio of lateral strain to the longitudinal strain. That implies sigma becomes lateral strain delta D change in diameter by original diameter divided by longitudinal strain, that is delta L by L, change in length by original length. That implies sigma is equal to delta D L by D into delta L. This is your Poissons ratio. The value of a Poissons ratio, its a theoretical value, should lie between (0.5 to -1 to 0.5). But its a practical value is between 0 to 0.5. This is theoretical value. But practical value of sigma is from 0 to 0.5. It may be defined as a ratio of two coefficient of elasticity, that is alpha 1 by alpha 2, where alpha 1 is the normal stress by longitudinal strain and alpha 2 is the normal stress by lateral strain. So by same normal stress we get two types of strain, one is longitudinal strain and lateral strain. So alpha 1, a coefficient of elasticity which defines ratio of normal stress to the longitudinal strain, and alpha 2 another coefficient of elasticity which defines ratio of normal stress to the lateral strain. So ratio of these two, alpha 1 and alpha 2, give us, that is the lateral strain by longitudinal strain. Normal stress will cancelled, so we get a ratio of lateral strain to the longitudinal strain. It is also defined as another coefficient of elasticity. It possesses no unit and a dimension. Jehetu same to physical quantity ratio, it has no unit and a dimension. We can establish a relation among elastic constants. Our derivation is out of course. We can derive it in higher classes. we have to only remember the formula. That is y, b, eta and a sigma. These are elastic constants. भितर आमर केते गुडी रिलेशन अछि y is equal to 2 eta into 1 plus sigma also we can write y as a 3b into 1 minus 2 sigma. Another relation 1 by b plus 3 by eta is equal to 9 by y. These are three relations relating different coefficients of elasticity. This is all about your topic, that is the elastic properties of a solid. We can solve many problems on different coefficient of elasticity. You have to do all the problems in your textbook. Thank you.